All right, so here we go with 1.4, perimeter and area in the coordinate plane. So a plane figure is our first vocab word, and it is a figure that lies in a plane. Simple enough, right? A polygon is a closed figure formed by 3 or more sides. Okay. Sides on a polygon are just line segments. Okay. And a vertex is each side intersects exactly 2 sides to make a vertex. So, for example, here's a side, here's a side, and here's a side. So each point where those meet is called a vertex. Okay, so that would have 3 vertex. All right, it says the number of sides determines the name of a polygon. You can also name a polygon using the term n-gon, where n is the number of sides. Okay, so if we're looking at our little table here, a 3-sided figure is called a triangle. A 4-sided figure, careful, is called a quadrilateral. We don't know exactly what size of each side is. Okay, so it's a quadrilateral. 5 is a pentagon. 6 is a hexagon. 7 is a heptagon. Heptagon, hepta. 8, like a stop sign, is an octagon. 9 is called a nonagon. 10 is a decagon. I think of like decade, decagon. And 12 is called a dodecagon. Okay, then if we just want to generalize, if we just have it in sides, we would just call it an n-gon. Okay, so now we have 2 different scenarios here. So if we have a convex shape, that means that there is no line that contains a side of the polygon that also contains a point in the interior of the polygon. Okay, I'll show you what that means in just a second. Okay, then concave, really their definition is not very good. It's not convex. So you got to know what convex means. Okay, which means that it does contain that interior point. Okay, I went ahead and added that myself so that it might make sense. Okay, so what that means is if I extend each side, you can see here that they've done that for you, of my shape. Okay, if it doesn't run in to the inside of the shape at all, that means that it is convex. Okay, so none of those do, so this would be a convex shape. Well, if I extend this side right here, that runs into the inside of that shape. Or you can see that these two sides here cave in, right? They cave inside. So that means that this shape here is concave. Okay, so you can remember it that way. All right, so then we're going to turn the page. Example 1 here, classify each polygon by the number of sides, then tell whether it is convex or concave. So I see 1, 2, 3, 4. So 4, if I look back, was a quadrilateral. That's why we don't call it a square, because that's not a square, right? That's just a 4-sided figure called a quadrilateral. And these two sides, if I were to extend them, right, they run onto the inside or they cave in. So this would be a concave shape. Okay, the next one, 1, 2, 3, 4, 5, 6. So that would be a hexagon. And those don't run into each other, so that would be convex. Okay. Now, finding perimeter and area in the coordinate plane, you guys might have, this might have been on the other page for you guys, and that's okay. Just keep rolling with me. If so, you should have seen that on the other page. Okay. So finding perimeter and area in the coordinate plane. You can use formulas given below and the distance formula to find the perimeters and areas of polygons in the coordinate plane. So let's talk about perimeter for each of these, and then we'll come back and talk about area, okay? Perimeter. Whenever I talk about perimeter, I'm talking about if I'm going to buy fencing to put up along the outside, right? Fencing goes on the outside of your property line, just like the perimeter goes on the outside of the shape. So to find the perimeter, I do capital P, and this would be A plus B plus C, because I can see that they labeled these sides A, B, and C. Okay, well, on a square, I know that all 4 sides are the same, and they labeled that side S, so I could just do 4 times S. Okay, now in a rectangle, I know that there's 2 sides that are the same, and then the other 2 sides are the same, right? So they labeled those W and L, so I could do 2 times L plus 2 times W. And that would give me the perimeter there. Again, if you just had a number, for example, on the square, say if S was 2, you could just do 2 plus 2 plus 2 plus 2 if you wanted, or it's just easier probably to do 4 times 2. Or here, say it was 2 and 4, you could do 2 plus 2 plus 4 plus 4, and it will give you the same answer. All right, now let's go back and talk about area. Okay, area is if I was buying like carpet to go inside of my room or inside of my house somewhere, right? So I want to know square feet usually whenever I'm putting down carpet. That's how you buy the amount of flooring that you want. Okay, so to do that, it's a capital A for area. For a triangle, it is 1/2 B times H. So you can see here the base is B, and H is the height of that triangle, okay? 1/2 base times height. And then a square is really the bottom times the side, but remember in a square, they're all the same. So in this case, it's just S squared. Okay, and then in rectangle, it's the same idea kind of as a square, the bottom times side, because that's base times height basically, or length times width in this case. Okay, same thing. All right, so using that now, let's go down here and we are going to find the perimeter of this triangle. Okay, so ABC, where A is at -2, 3. Here's A. B is at 3, -3. Again, make sure we're labeling everything. C is at -2, -3. All right, well, I see that I have 2 of my sides that are straight up and down or straight side to side. So when that's the case, remember I can do the absolute value to save me some time, okay? Or worst case scenario, you can always use the distance formula. It'll always work too, okay? So in this case, I'm gonna do AC. So if I'm looking at A and C, I can see that they both have a -2 in the x, so I don't want to look at that because that would tell me 0. So instead, I'm going to look at 3 and -3. So I get -3 minus 3, which is -6, which is 6. So I could go back and I could count to make sure I'm right. 1, 2, 3, 4, 5, 6. Yep, I did it right. Okay. Now BC is also straight. So B and C, they both share a -3 in the y place. So the x's now is what I'm going to look at. I'm going to do 3 minus -2 becomes +2, which is 5. Let me double check. 1, 2, 3, 4, 5. Yep. So there's my work showing my answers. Okay, now the last one, AB, I have to do the distance formula. So I'm going to do the big square root. A and B, I'm going to start with A just because it's first. So -2 minus 3 squared plus, if I started with -2, I have to start with the 3 that goes with that. So 3, and then the other y value is -3. So 3 minus -3 becomes +3 squared. -2 minus 3 is -5, so keep it in parentheses. Plus 3 plus 3 is 6. -5 squared. -5 squared is telling me to do -5 times -5, which would give me 25. Okay, and 6 times 6 is 36. 25 plus 36 is 61. Okay, and again, I want to know a perimeter, so I actually do need the decimal value here. So second square root 61 is 7.8. Okay, so to find the whole perimeter now, I need to add up 6 plus 5 plus 7.8, and that would give me 18.8 units. Okay, that would be my final answer. Okay, again, if you guys have the next one on the same page, the example 3, you can keep it there. I need to turn mine because it printed out weird. Okay, so example 3 says finding area in the coordinate plane. Excuse me. All right, so it says find the area this time of triangle DEF with vertices of D at 1, 3. E is at 4, -3. And F is at -4, -3. Okay, so area of a triangle, remember, is 1/2 base times height. Okay, so the base I know is this bottom length FE. So B equals FE. Okay, well, FE, if I'm looking here, those both have -3 in the y's. So let's look at the x's. 4 minus -4 becomes +4, which is 8. Let's count 1, 2, 3, 4, 5, 6, 7, 8. I did that right. Okay, now my height. Well, DF isn't my height because that's slanted. DE is not my height because that's slanted. Well, I'm going to have to drop my own height. Okay, so I want to drop it straight down from D. We can call this new point, say, N. Well, N is at 1, -3. And it starts from D, which is at 1, 3. Well, they both have 1 in the x's, so let's look at the y's. So my height is DN, which is 3 minus -3 becomes +3, which is 6. Let me double check. 1, 2, 3, 4, 5, 6. That's right. All right, so then area equals 1/2, 8 times 6, or 1/2 of 8 is 4 times 6, which is 24. And that would be units. But again, whenever I'm talking about area, it's squared. So the area is 24 units squared. Just like whenever you would go buy carpet, I would tell them I need blank square feet. Okay, that's where that square comes into play. All right, now if you need to turn the page, you can turn your page to get to the last one. If not, you're following here along with me. Okay, it says you are building a shed in your backyard. The diagram shows the 4 vertices of the shed. Each unit in the coordinate plane represents 1 foot. Find the area of the floor of the shed. Okay, well, we just need to find the area then of that either rectangle or square. I got to figure out what it is. So let's find what, that's not a G. Let's find out what GH is. Okay, so let's see, G to H, they both have 7, so I don't want to look at that. So instead, let's look at 2 and 8. So 2 minus 8 is -6. Absolute value of that just comes out to be 6. All right, well then let's find out what GK is. They both have 2's here, so actually I want to look at 7 and 2. 7 minus 2 is 5. Okay, well then it's not a square, it's a rectangle. Okay, and I know with a rectangle, area is length times width. So the area here is 6 times 5, which is 30. And it said that each unit represents 1 foot. So I don't have to multiply by anything, because if I multiply by 1, it's just going to stay the same. But I need to label it with feet squared. And there's my final answer. Let me know if you have any questions.